Hello Stormwater designers, and welcome back to Clear Creek Solutions hydrology education videos. Today we're going to be going over climatology. So let's dive right in. Climatology is the study of long-term weather patterns that shape our environment. So unlike weather, which can change from minute to minute, climatology looks at decades of data to reveal trends. So in this presentation, we'll explore how climatology provides the foundation for hydrology and stormwater modeling, and where engineers can find the climate data they rely on. So weather represents the short-term state of the atmosphere, which is today's rain, wind, or temperature. Climate, on the other hand, represents the statistical average of the weather over 30 years or more. And for engineering purposes, climate data is essential because it smooths out daily variability and provides reliable baselines for design storms, flood frequency, and risk management. So without climate baselines, infrastructure design would be based on guesswork, but climatology provides recurrence intervals for rainfall events, guides urban flood risk assessments, and ensures drainage systems meet regulations. So when we talk about why climatology matters, we're looking at these main four components: predicting flood risk, sizing stormwater infrastructure, support compliance and safety. Climatology provides recurrence intervals for rainfall events, guides urban flood risk assessments, and ensures drainage systems meet regulations. And this discipline connects science to engineering decisions. So rainfall is the driving force behind runoff. Engineers rely on rainfall intensity, duration, and frequency statistics to create hydrographs and test different design storms. Long-term precipitation records are critical to simulate realistic site behavior. For example, a 100-year, 24-hour storm is derived directly from climatology rainfall data. So when we look at that key variable of rainfall, we have it being the most important variable, the driving force behind runoff, using intensity, duration, and frequency, and drives the creation of hydrographs and design storms. Temperature also influences water movement in multiple ways. In colder climates, it determines snow accumulation and melt, which can cause spring flooding. And in warmer regions, higher temperatures accelerate evaporation and alter soil moisture. Temperature data ensures that long-term models account for seasonal and regional variation. Now, we have to talk about evaporation and evapotranspiration, which we're using the letters ET to transcribe. So evaporation and evapotranspiration represent how water leaves the surface and vegetation. ET, or evapotranspiration, is the combination of evaporation from soils and open water plus transpiration from plants. Evaporation is just going to be direct water to atmosphere transition. These processes reduce runoff potential and are especially important in long-term hydrology simulations and water balance studies. So while rainfall, temperature, and evaporation dominate hydrologic modeling, secondary climate factors also matter. Wind can increase evaporation and drive storm formation, while humidity influences evapotranspiration rates. Pressure and soil radiation are also used in advanced climate models to simulate long-term system changes. So, hydrology transforms climate inputs into runoff predictions, and rainfall time series generate hydrographs, graphs of flow over time. Temperature and evaporation data refine those results to reflect seasonal variability and storage losses. Accurate climate data ensures runoff models represent reality instead of just working theory. So how does SWMM use climate data? EPA SWMM requires climate data to function correctly. Rainfall time series drive simulations, evaporation helps with continuous water balance, and snowmelt routines rely on temperature. Advanced options let SWMM read climate files for evaporation and wind speed. This allows engineers to replicate local conditions and improve accuracy. So in the United States, NOAA provides datasets like Climate Data Online and U.S. Climate Normals. These resources include decades of precipitation and temperature records used for design storms and hydrology modeling, and globally, NASA also maintains climate databases accessible to researchers and engineers worldwide. So, climatology is the foundation of stormwater design. It turns decades of water into practical data for infrastructure and compliance, and by understanding rainfall, temperature, and evaporation patterns, engineers can design systems that protect communities from flooding. These are the various works that were referenced. We also have some free guides and materials for you. So at Clear Creek Solutions, we have a free EPA SWMM course which you can access in the description down below, containing 24 videos teaching you how to use EPA Swim at a basic level. If you have any questions, please contact us in the comments down below. Thank you so much for watching. And anyways, we will see you guys in the next video.